Hello everyone, welcome back to our Introduction to Economics course. In the previous lesson, we learned how opportunity cost and the production possibilities curve, or PPC, help us understand scarcity, trade-offs, efficiency, inefficiency, and unattainable points. In today's lesson, we will go one step further. We will learn how to calculate opportunity cost, and we will study three important opportunity cost patterns: increasing, decreasing, and constant opportunity cost. You may be wondering, why do we need to study different opportunity cost patterns? The reason is simple. In real life, not all trade-offs behave in the same way. Sometimes giving up one good gives us a small amount of another good. Sometimes the cost gets larger and larger. In other cases, the cost stays the same. By studying these patterns, we can better understand how resources are used and why the shape of the PPC matters. Before we begin calculating, let's quickly review the meaning of opportunity cost. Opportunity cost is the value of the next best alternative given up when a choice is made. In PPC analysis, opportunity cost usually means how much of one good must be given up to produce more of another good. So, when we move from one point to another point on the PPC, we can measure the trade-off between the two goods. Let's use a simple example. Suppose an economy can produce only two goods, computers and rice. Of course, real economies produce many goods, but economists often simplify the world so we can clearly see the main idea. The PPC shows different combinations of computers and rice that can be produced with available resources and current technology. Imagine the table shows 5 production choices. At point A, the economy produces 0 computers and 100 tons of rice. At point B, it produces 10 computers and 90 tons of rice. At point C, it produces 20 computers and 70 tons of rice. At point D, it produces 30 computers and 40 tons of rice. At point E, it produces 40 computers and 0 rice. The table helps us see how much rice must be given up as the economy produces more computers. To calculate opportunity cost on the PPC, we look at what is gained and what is given up. The basic idea is opportunity cost equals what we give up divided by what we gain. If the economy moves from point A to point B, it gains 10 computers but gives up 10 tons of rice. So the opportunity cost of 10 more computers is 10 tons of rice. That means the opportunity cost of one computer is 1 ton of rice. Now let's move from point B to point C. Computers increase from 10 to 20, so the economy gains 10 computers. Rice decreases from 90 to 70, so the economy gives up 20 tons of rice. The opportunity cost of 10 more computers is 20 tons of rice. That means the opportunity cost of one additional computer is 2 tons of rice. Notice what happened. Moving from A to B, one computer cost 1 ton of rice. Moving from B to C, one computer cost 2 tons of rice. The opportunity cost increased. This is important because it tells us that the trade-off is becoming more expensive. The more computers the economy produces, the more rice it must give up for each additional computer. If we continue from point C to point D, computers rise from 20 to 30, so the gain is 10 computers. Rice falls from 70 to 40, so the economy gives up 30 tons of rice. The opportunity cost of one computer is now 3 tons of rice. From point D to point E, the economy gains another 10 computers, but gives up 40 tons of rice. Now the opportunity cost of one computer is 4 tons of rice. This example shows increasing opportunity cost. Increasing opportunity cost means that as we produce more of one good, we must give up larger and larger amounts of the other good. This is the most common PPC pattern in economics. It is usually shown by a PPC that is bowed outward from the origin. Why does increasing opportunity cost happen? The main reason is that resources are not perfectly adaptable. Some resources are better suited to one type of production than another. For example, some land is better for farming, while some workers or machines may be better for producing computers. As we move more resources from rice production to computer production, we eventually use resources that are less suitable for computers. That makes each additional computer more costly in terms of rice given up. Think about a country that produces both food and cars. At first, it may move workers and machines that are easily used in car factories. The opportunity cost may be small, but later, if the country wants even more cars, it may have to move farmers, farmland, and agricultural equipment away from food production. Those resources may not be very good at producing cars. As a result, the cost of producing additional cars increases. When opportunity cost increases, the PPC is usually bowed outward. The curve becomes steeper as we move along it in one direction. A steeper curve means more of the good on the vertical axis must be given up to gain one more unit of the good on the horizontal axis. So the shape of the PPC gives us information about opportunity cost. Now let's look at a second pattern, constant opportunity cost. Constant opportunity cost means the opportunity cost stays the same as production changes. If one additional computer always costs the same amount of rice, then the opportunity cost is constant. On a graph, constant opportunity cost is shown by a straight line PPC. Constant opportunity cost can happen when resources are equally adaptable between two uses. In other words, the resources can be moved from producing one good to producing another good at a constant rate. For example, if one worker can produce either 2 notebooks or 1 folder with the same skill and productivity, then the trade-off may remain constant. This situation is less realistic for a whole economy, but it is useful for understanding the basic idea. When reading a straight line PPC, the opportunity cost does not change as we move along the line. If every movement gives up the same amount of one good for the same gain in the other good, then the cost is constant. The slope of the line is the same everywhere. This makes the calculation easier because the opportunity cost per unit remains unchanged. The third pattern is decreasing opportunity cost. Decreasing opportunity cost means that as we produce more of one good, we give up smaller and smaller amounts of the other good. This is shown by a PPC that is bowed inward toward the origin. This pattern is less common in introductory economics, but it is still useful to understand because it helps us see how PPC shape and opportunity cost are connected. Decreasing opportunity cost can occur in situations where production becomes easier or more efficient as more of a good is produced. For example, workers may learn by doing, or production may benefit from better organization as output expands. In this case, each additional unit may require giving up less and less of the other good. Again, this is not the most common PPC shape, but it is important to recognize the pattern. Now, let's compare the 3 shapes. A bowed-out PPC shows increasing opportunity cost. A straight-line PPC shows constant opportunity cost. A bowed-in PPC shows decreasing opportunity cost. When you look at a PPC, do not only ask where the points are. Also ask what the shape of the curve tells you about the opportunity cost pattern. When interpreting a PPC, always pay attention to direction. If we move from left to right along the curve, we usually gain more of the good on the horizontal axis and give up some of the good on the vertical axis. If we move in the opposite direction, we gain more of the vertical axis good and give up some of the horizontal axis good. Opportunity cost always depends on what you are gaining and what you are giving up. Let's return to our computers and rice example. Earlier, we calculated the opportunity cost of producing more computers in terms of rice, but we can also calculate the opportunity cost of producing more rice in terms of computers. If we move from point C back to point B, rice increases from 70 to 90, so the gain is 20 tons of rice. Computers fall from 20 to 10, so the economy gives up 10 computers. The opportunity cost of gaining 20 tons of rice is 10 computers. Sometimes we want opportunity cost per unit. In the reverse example, 10 computers are given up to gain 20 tons of rice, so the opportunity cost of 1 ton of rice is 1/2 of a computer. This reminds us that opportunity cost can be calculated in either direction. The key is to clearly identify what is gained and what is given up. One common mistake people make is mixing up what is gained and what is given up. To avoid this, always ask 2 questions. First, what did we gain by moving from one point to another? Second, what did we give up? Once you answer those 2 questions, the calculation becomes much easier. Opportunity cost is always based on the thing sacrificed to get something else. Another common mistake is ignoring the shape of the PPC. People sometimes think every PPC has the same opportunity cost pattern, but the shape matters. If the PPC is bowed outward, opportunity cost is increasing. If it is straight, opportunity cost is constant. If it is bowed inward, opportunity cost is decreasing. Reading the shape is part of interpreting the model correctly. Let's do a quick practice example. Suppose an economy moves from producing 5 machines and 50 units of food to producing 10 machines and 35 units of food. What is the opportunity cost of producing 5 more machines? The economy gained 5 machines and gave up 15 units of food. So the opportunity cost of 5 machines is 15 units of food. The opportunity cost of 1 machine is 3 units of food. These calculations are not only about graphs. They teach us a way of thinking. Whenever resources are limited, choices involve trade-offs. A student choosing study time, a business choosing production plans, or a government choosing between public services all face opportunity costs. Remember, the PPC helps us visualize these choices, but the real idea applies far beyond the classroom. Let's review today's key points. Opportunity cost is what we give up to gain something else. To calculate it, divide what is given up by what is gained. Increasing opportunity cost means the cost rises as more is produced, and it is shown by a bowed-out PPC. Constant opportunity cost is shown by a straight line PPC. Decreasing opportunity cost is shown by a bowed-in PPC. The shape of the PPC helps us read and interpret trade-offs more clearly. Thank you very much for joining me in Lesson 4 on opportunity cost patterns in the PPC. In this lesson, we have learned how to calculate opportunity cost and how to read different PPC shapes. Before we end today's video, stay with me for a quiz challenge in the next section. Question number 1. What type of opportunity cost does this straight line PPC show? A. Increasing opportunity cost. B. Decreasing opportunity cost. C. Constant opportunity cost. D. No opportunity cost. The correct answer is C. Constant opportunity cost. A straight line PPC shows constant opportunity cost. This means the same amount of one good is given up each time to gain more of the other good. Here's question number 2. What type of opportunity cost does this PPC show? A. Constant opportunity cost. B. Unattainable opportunity cost. C. Decreasing opportunity cost. D. Increasing opportunity cost. Notice that the curve is bowed outward. Ask yourself whether the trade-off becomes larger or smaller as production increases. The correct answer is D, increasing opportunity cost. A bowed-out PPC shows increasing opportunity cost. As the economy produces more of one good, it must give up larger and larger amounts of the other good. Question number 3. What type of opportunity cost does this PPC show? A. Efficient opportunity cost. B. Constant opportunity cost. C. Decreasing opportunity cost. D. Increasing opportunity cost. This curve is bowed inward toward the origin. Think about whether the amount given up becomes smaller or larger. The correct answer is C. Decreasing opportunity cost. A bowed-in PPC shows decreasing opportunity cost. This means the economy gives up smaller and smaller amounts of one good as it produces more of the other good. Moving on to fill in the blank questions. Question number 4. Opportunity cost is calculated by dividing what by what is gained. Here's your hint. Think about the thing that is sacrificed in order to get something else. If you said given up, you are absolutely correct. Opportunity cost is calculated as what is given up divided by what is gained. The key is to clearly identify both parts before calculating. Question number 5. The PPC that is bowed outward shows what opportunity cost? Here's your hint. This is the most common pattern in economics. The trade-off becomes more expensive as production increases. If you said increasing, you are absolutely correct. A bowed-out PPC shows increasing opportunity cost because larger and larger amounts of one good must be given up to gain more of the other good. Question number 6. A straight line PPC shows what opportunity cost? Here's your hint. The cost stays the same as production changes. If you said constant, you are absolutely correct. A straight line PPC shows constant opportunity cost because the same amount of one good is sacrificed each time. Moving on to short answer questions. Question number 7. Explain the difference between increasing, constant, and decreasing opportunity cost using PPC shapes. Here's your hint. Think about the 3 main shapes: bowed out, straight line, and bowed in. Here's a sample answer. Increasing opportunity cost is shown by a bowed out PPC. It means the cost rises as more of one good is produced. Constant opportunity cost is shown by a straight line PPC. It means the same amount of one good is given up each time. Decreasing opportunity cost is shown by a bowed-in PPC. It means smaller and smaller amounts of one good are given up as more of the other good is produced. Question number 8. Why is it important to pay attention to the direction of movement on a PPC? Here's your hint. Think about moving left to right versus right to left along the curve. Here's a sample answer. Direction matters because opportunity cost depends on what is gained and what is given up. If we move left to right, we usually gain more of the good on the horizontal axis and give up some of the good on the vertical axis. If we move right to left, we gain more of the vertical axis good and give up some of the horizontal axis good. Here's question number 9. Suppose an economy moves from producing 5 machines and 50 units of food to producing 10 machines and 35 units of food. What is the opportunity cost of producing 5 more machines? What is the opportunity cost of one machine? Here's a hint. First, find what is gained. Then find what is given up. Use the formula. Opportunity cost equals what is given up divided by what is gained. Here's a sample answer. The economy gains 5 machines because production rises from 5 to 10 machines. It gives up 15 units of food because food falls from 50 to 35. So the opportunity cost of producing 5 more machines is 15 units of food. The opportunity cost of one machine is 3 units of food. Great job! You made it to the end of today's lesson on opportunity cost patterns in the PPC and completed the quiz challenge. Thank you for watching today's lesson. Until next time, take care.